So the exact value stuff I'm about to do is important, and it will definitely come up in your exam, and I can guarantee it'll come up in your external exam next year. Something to do with exact values will come up in your external exam. It's a really easy one for them to transfer across, but in real life it's not that important. There are not many situations where you get the exact values that come out. So before I do this, I just want to map out a couple of relationships. The first one is that 30 degrees is equal to pi over 6 radians. The second one is that 45 degrees is equal to pi over 4 radians. And the third one is that 60 degrees is equal to pi over 3 radians. Now I'm going to show you so that you know the exact values of sine, cos and tan of each of these three angles. And that will mean that you also know the exact values of sine, cos and tan of each of these three angles when they're in the second, third and fourth quadrant, or even if they're 2 pi, 4 pi, 6 pi, extra rotations around. You'll know all those exact values. But they are only the 30, 45 and 60. If you go on and do some work in specialist maths, you'll also learn how to use these exact values and some other trig identities to determine the exact values of sine, cos and tan of 75 degrees or 15 degrees. So there's extra ones we can do as well. But for now, these are the only ones you need to know from math methods. So let's start by drawing a completely made up, for the right reasons, diagram. Okay, there it is. This, I'm going to say, and no one comment on my drawing here, is an equilateral triangle. Equilateral triangle, what do we know about an equilateral triangle? All the sides are equal, and all the angles are equal. The sum's to 180, so what are all the angles equal? 60, excellent. All the angles are 60, so I could write in 60 here, but I could also recognise that that's pi on 3. So I've got those two angles there, 60 or pi on 3. Angles are equal, that's my little symbol for angles, and side lengths are also equal. So I'm actually going to put side lengths on here, and again this is entirely arbitrary, but there's a good reason why I'm choosing it. But let's say all the sides are 2. Now let's say I get this triangle and I drop a vertical line from the apex down to the base, and because it's an equilateral triangle, that happens to bisect the base. So that vertical line does two things. First, it creates a right angle, and it bisects the base, splitting into 1 and 1. And then I'm going to get this part of the triangle, and I'm going to whiz it away over here and redraw it. So here's my new triangle. 1, 2, pi on 6, pi on 3. Yeah, that's right, I got that right over there. Can you tell me the other two pieces of information in this triangle? I need the other angle, and I need the other side length.
Is the other side what?
No, it's not, but good guess, I could see it. Harvey? Pi on 6 is the other angle. And the other side, it's not 1. It's also not 2 because it can't be longer than the hypotenuse. 1.5. Let's keep on guessing, shall we? It's irrational, so we'll be guessing forever, but no, let's carry on. Root 2. No. But you're on the right track. Root 3 is right. Okay, so just don't forget that we have Pythagoras' theorem, gives us 2 squared equals, that's not an equals 1 squared plus h squared, where I've just sort of called that h. And we rearrange that, we get root 3, okay? So there's all the information in the triangle. This information gives us these values. So I'm going to write down pi on 3, no, I'll do pi on 6 first, which is 30 degrees, and pi on 3, and pi on 6 is 30 degrees, pi on 3 is 60 degrees, and I'm going to work it out for sine, cos, and tan. These are my exact values. Now, sine of pi on 6 is opposite over hypotenuse. So would you believe it? Sine of 30 degrees is actually 1 over 2, a half. You can try it in your calculator if you want. That is an exact value. I've got another question I'll ask in a second. Cos of pi on 6. Can somebody tell me what that is? Baxter, sorry? I am waiting. Millions of my subscribers right now are waiting for this blank space to fill up. Root 3 over 2. So I've got 1 over 2, root 3 over 2. What about 10? Just root 3. Root 3 over 1, which is just equal to root 3. Oh, is it? No, I don't think it is. 1 over root 3. Okay, why is this why would we call this and put this under the umbrella exact values?
Because it doesn't have a decimal point that's been rounded.
It doesn't have the
Decimal point that's been rounded.
Doesn't have the decimal pointing around it. Because we've used surds, this is an exact value. We know exactly what that's equal to. If you do cos of 30 degrees in your calculator, it will probably give you 0.866. As soon as you get 0.866, rounding has occurred and you've got an issue. So it'll probably give you 0.866, but if you get it set up, you get your calculator set up so it gives you exact values, it will give you root 3 over 2. And then you're salvaging some of that rounding. That's why we call it exact values. Pi on 3, can somebody give me these ones? Root 3 over 2. 1 over 2. Reggie? Root 3. Root 3 over 1 or root 3. Perfect. So these are our first 6 exact values. They're not, in fact, I don't even encourage you to memorise them. Don't memorise them. 2 things. Well, I can't say this anymore. I used to be able to say, look, just type in cos of 30 in your calculator, it will give you the exact value, and we can't expect you to memorise it. But you don't really have that luxury anymore because you have a tech-free exam. And this will come up in your tech-free exam almost certainly. So in fact, I'm going to tell you right now, it'll come up in your tech-free exam in term 3. So you need to either memorise them, or better yet, this is what I would do, memorise this. Know that triangle, and then you've got all 6 of them. Done. No problems at all. That's what I would be doing, okay? If you practice these, and you do a lot of questions on these just stick. So I know that sine of 30 is a half, which means I know cos of 60 is a half, which means I know that the other 2 are the root 3s on 2s, and I've just got to deal with tan. And that was all coming from just one piece of knowledge, straight up. Here's the other amazing thing. Do you remember earlier we did that extension question where we determined that sine of pi on 2 minus theta equals cos of theta? Look at this inverse relationship we get here. Cos of 30 is equal to sine of 60. Cos of 60 is equal to sine of 30. How amazing is that? I think it's amazing. Let's leave it at that. Okay, last one. This one's a little bit smaller. Let's start with our arbitrary diagram again. This time it's going to be a triangle that looks like this. What kind of triangle do you think I'm trying to draw? It is right angled and it's an isosceles. Good. So has 2 equal sides. Isosceles, that means that these 2 angles here are equal. Doesn't even really look like a triangle to be honest, does it? This is a right angle, so some people worked out that. So what are those angles? 45, which as a radian is? Pi over 4. Now, time for my arbitrary side lengths. 1 and 1. And Harvey, what's the hypotenuse?
1.
No. I picked you because I picked you for a very specific reason. Sorry? Root 2? I hope that's what you said. If it isn't what you said, then I've just given you the answer. So well done. No, I'm sure that's what you said. So 1, 1, root 2, there's my triangle. And so again, I've arbitrarily made these up, but it wouldn't really matter if you made it 10 and 10. It's an isosceles triangle, and it's got a internal angle of 45 degrees and a right angle, which means I can use right angle trig. And that gives me these ones. Pi on 4. Let's blow that up a bit. Let's make it big. Pi on 4. And this is 45 degrees. And we're going to do sine, cos, and tan of that angle. So sine of pi on 4. Any takers? 1 over root 2. Cos of pi on 4. Tan of pi on 4. So just 1, yeah? And that's it. There's our exact values for pi and 4. So if you ever get a question that has tan of 45, you know it's 1, because that's one of our exact values. If you want to help you memorise it, I would have those on a piece of paper, stuck up at your desk at home, or stuck in your book, pull it out. Whenever you're doing these questions, just have it in front of you. There's no harm in you having that in front of you now and getting used to it. As you do your revision, 3-4 weeks out from your exam in term 3, then you might take that away and start to make sure you know the things. But if you're using it a lot now, you will find that it just ends up in here. It's just there. And that's what I'd be encouraging you to do. I would add to your table these values as well. So I'm just going to make an addition. Here's the first part of the table. Here's the second part of the table. And then I would add to your table the zeros and the 90s. And then you can extrapolate anything from there. So the zeros and the pi on 2, which is 90, for sine, cos, and tan.
Wait, but doesn't tan not exist at 90 degrees?
At one of them it doesn't, yep, but we'll get there. Sine of 0 is what? The height on the positive x-axis when we move 0 degrees. 0. Cos of 0? 1. Tan of 0? Which is sine divided by cos is 0 divided by 1 is 0. Sine of 90? 1. Cos of 90? 0. And 1 divided by 0 is undefined. So math error, NA. So that will exist as well. So that's undefined, but you've got those extra 5. If you know those 5 angles, you can extrapolate beyond. And here's my examples of these now, and you'll get your chance to extrapolate beyond. When you're doing this exercise, I'd strongly encourage you to do this exercise without a calculator. So it's 15F, and I'll give you time. You're not going to have much time today, but I'll give you time on Friday to do it. 15F. So example 3, calculate the value of cos 5 pi on 4. So this is an exact value. Yep, there's little kids running. Don't be distracted by them. The first thing I'm going to do, and hopefully the first thing that you will do in almost every case, is draw a unit circle and locate your angle. Draw a unit circle, locate your angle. Here's my circle. That wasn't bad actually, I'll take that. 5 pi on 4. So if I go around and mark all these, 0, pi on 2, pi, 3 pi on 2. 3 pi on 2 is the same as 6 pi on 4, which is beyond 5 pi on 4. Pi is the same as 4 pi on 4. So 5 pi on 4 is here. That's 5 pi on 4. And you'll notice here that 5 pi on 4, if I draw this little angle in there, that is pi on 4. So now I'm going to backwards design the equivalency of the angles to get it into the first quadrant so I can go back and use my exact values. So if I backwards design this, the second bit is the other diagonal. Remember, we're dealing with the diagonals of that rectangle, which I haven't drawn. And if this is pi on 4, then this angle here will be pi on 4. And I want to determine cos of 5 pi on 4. So cos of 5 pi on 4 will be equal to cos of pi on 4. This is the first quadrant. This is in the third. This is in the first. And then I do my little cast diagram check. CAST is cos positive or negative in the third quadrant? Negative, and therefore it'll be negative of the first quadrant answer. And can somebody refer to their table and tell me what cos of pi on 4 is? 1 on root 2. Okay, go back to that pi on 4 table. Cos of pi on 4 is 1 on root 2. So cos of 5 pi on 4 is in the third quadrant. It's equivalent to the cos of pi on 4, but it's negative because it's in the third quadrant, so we get negative 1 on root 2. Any questions on that? And that all comes from a good unit circle. Not a perfectly drawn circle, but just a good informative unit circle will get you there. Here's another one. Calculate the value of sine 11 pi on 6. I might make my unit circle a bit bigger this time. Did you know there's an international circle drawing competition?
No way, that's so cool.
True, there's YouTube videos of people, they stand up at a whiteboard like this, and they just go, whoof, and it's a perfect circle.
How do they judge it, though?
They go around and they locate the central point by drawing, they basically draw diameters on there, and they check that all the diameters are the same length.
That's pretty cool.
Yeah, so they go.
Subscribers are really happy right now.
Anyway, so that's a distraction. 11 pi on 6. This is pi on 2. This is pi. That's as far as I have to go. Is it? No, it's not. 3 pi on 2, and this is 2 pi. 11 pi on 6. 2 pi is 12 pi on 6, so it's not quite to 2 pi. 3 pi on 2 is equivalent to 9 pi on 6. So I can see it's in the form. It won't be much work. So I'm going to draw that in my egg. There it is there. This is my 11 pi on 6. And the difference between 2 pi and 11 pi on 6, because this is my angle to my horizontal I want, that is pi on 6. And that's equivalent in the first quadrant to this angle, pi on 6. So I've got my 11 pi on 6 now. I do my cast diagram, CAST, and now I can make this statement. Sine of 11 pi over 6 is equal to sine of pi on 6. That's in the first quadrant now. But I just have to check my cast diagram. Is sine positive or negative in the fourth quadrant? It is negative, and so I pop a little negative sign in front. And can somebody go back to their table of exact values and tell me what sine of pi on 6 is?
It's 1 over 2.
1 over 2, perfect. So I get negative 1 over 2. Okay? I locate unit circle, locate the angle. Once I've located the angle, I need to know the difference between that angle and the x-axis, positive or negative, doesn't matter. I just need to know this angle here, or over here, or over here, because that will be the same angle that's in the first quadrant. That's where the equivalency will come, and then I just do my cast diagram check, bam, I'm done, every time. That's all you need to do. And these exact values, it's a really good way to practice this skill before you have to deal with irrational radians that are hard to determine. Like example 5, for example. Determine the first quadrant angle that tan 5.6 radians is equivalent to. So here's my last question, and I should be able to finish it. I'm going to draw another egg. It is close to Easter after all. It's a spiral. There's my spiral, tan of 5.6 radians. Now, this is pi on 2, this is pi, this is 3 pi on 2, and this is 2 pi. Now, I know that pi is 3.14, so this is 3.14, and I know 2 pi is 6.28, because I can do some multiplication. And I think that 3 pi and 2 is about 4.57, but I'm not 100% sure. But I know it's definitely less than 5.6, and you can work those things out in your calculator, because this is not in terms of pi. But 5.6 is about here somewhere, and the difference 2 pi and 5.6 radians is this angle here, 2 pi minus 5.6. Whatever that is, it's about 0.68. If I do the 6.28 minus 5.6. But you know what, I want to keep things exact if I can. So I'm going to stick with the 2 pi minus. That's equivalent to this, which is just 2 pi minus 5.6, which is approximately equal to 0.68. And so that means that tan of 5.6 radians is equal to tan of 2 pi minus 5.6 radians. But I've checked in that first quadrant and the fourth quadrant, and based on my cast diagram, CAST, I can see that tan is negative. And so now I just make this negative, and the alternate is I could write it down as negative tan of 0.68. You'll notice here, the question says, determine the first quadrant angle that tan of 5.6 radians is equivalent to. It's not asking you to determine what 5.6 radians, tan of 5.6 radians equals. just asking to find the first quadrant angle. So we get here, we find the right quadrant, and then we bring it across to there. So in this case, the answer is probably 0.68. There it is. Thanks, ladies and gents.